Another exciting day, mathematics. Warm-up 54 is on the screen. Hopefully by now you got all these four by yourself in no time. Get cracking, please. Go. And I could have been a singer. Let's go. All right. Number one. Let's see. Let's get the show on the road. Give us an inequality for number one, please. How about we start with Mariah? How about them apples? All right, Mariah. I'm going to give you the solution set of x such that, and give us the inequality, please. -4. Ooh-wee. Hands, if you got that. That is correct. And notice, since it was an open point here, that's why we didn't put an equal sign on that one. Okay. Number two. The next person's going to help me work this one out completely. So check with your neighbor, see what they did for number two, and then Mariah is going to pass it to someone. Number two. All right, Mariah, pass someone. Mario, what do I do? Cross multiply. So we end up with -3x minus 6 equals 2x squared minus 4. So far, so good. Next step, what do I do? Plus 3x plus 6 to both sides. Plus 3x plus 6. We end up with 0 equals x squared plus 3x plus 2. What do I do? 2 and 3, factors of 2 that add up to 3. 2 and 1, so my factors are x plus 2, x plus 1, all that equal to 0. Then what do I do? X plus 2 equal to 0. And we solve. -2 minus 2. X equals -2. -1 minus 1. X equals -1. Hands, if you got that by yourself. All right, not bad. For number 3, we need an equation. I'll get you started, and Mario's going to pass it to someone. Y equals mx plus b. Y equals blank x. Tell your neighbor what you got, please, before Mario passes it to someone. Check with your neighbor. All right, Mario, pass someone. Enrique, y-intercept. 2, there it is, plus 2. And we need a rise over run. So let me add another point. Let's see, how about this one right there? So we're going from here to there. Therefore, what's our rise over run? Three over 2 looks about right. And then all we need is to change it to function notation, f of x. 3 over 2x plus 2. Hands, have you got that? All right. And last but not least, number 4, inverse. Check with the neighbor what they got for the inverse, and then we're going to have Enrique pass someone. Inverse for number 4. All right, Enrique, pass someone. Mario, what's the first thing we do? Y equals -2x plus 12. Next, what do I do? Subtract 12 from each side. So then we end up with y minus 12 equals to -2x. And then divide by -2. We end up with y minus 12 over -2 equals x. So that's not the inverse. Tell your neighbor how we make that an inverse. How do we make that an inverse? Then Mario's going to pass it to someone to enlighten us. All right, Mario? Pass someone. Gio, how do we make that an inverse? Yeah, you substitute the x and the y. You switch them. So we end up with x minus 12 over negative 2 equals y. This is the inverse. However, we need to change that to f of x. X minus 12 over negative 2. And to make sure that we know that this is an inverse, we write a little negative 1 right there. And if you got that by yourself. Yeah, some of us. Send that in, please. And copy the agenda, warm-up number 54, transforming functions. Home plate for tonight, 2 problems only. How was home plate last night? Good? Yeah? Okay, good. Yeah, I don't think I'm going to pick up home play. It's free from me to you. Extra practice, yeah? Some are like, yes. Psych, I am going to pick it up. Let's go. Go to Canvas, turn it in. And actually, it counts as a pop party. Oh, man, I got this. Copy the code for tonight's home play, LV5E7. 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 That's nice. Is this one very simple, yeah? Only one problem, and I'm pretty sure you did that by yourself. Counts as a pop party. Tonight's, though, woo-wee. Good thing you practiced last night, because today's going to be a doozy. Let's go. All right, get a Cornell note ready. Also, make your way to the back, get a handout. You're going to need one for the session. Give you some time. Go. All right, here we go. I can transform a function using different parameters. I can transform a function using different parameters. I can transform a function using different parameters. Look up to the screen. Here we go. So, we know by now what functions are. Is that correct? Yes, Mr. Q. Remind your neighbor, definition for functions. What are functions? Tell your neighbor, please. What are functions? All right, looks like Joseph's got it, but let's go with Renzo. Definition. Woo! A relation that for every input, there's an output. That is correct. One for each. From there, we talked about parameters. We said parameters are numbers that change one function into another. And I introduced 3 parent functions, f of x equals x, f of x equals x squared, and f of x equals x cubed. And notice on this one, as soon as I did x plus 4, it changed the original to a new one, and we changed the f of x to g of x. Same thing on this one. X squared minus 5, I did minus 5 to the x squared, so it changed it. So we changed f of x to g of x as well. Same thing for this one, x cubed, we multiply times 5, so instead of being f of x, it's g of x equals 5x cubed. From there, we talked about that this is our general rule. Is that correct? Caesar, yeah? And then from there, we went to these. We did some examples. To this one, we also did examples. And then we found out that on our general rule, then that h and k are called what? Parameters, yes? And those parameters move an original graph to a new position, to a new graph. And that's what we call transformation. So k moves it up if it's positive, moves it down if it's negative. And H moves it to the right if it's positive and to the left if it's negative. So far so good, yes? Yes, Mr. Q. And then yesterday we did this one. There are all the transformations. This one, transformation, a combination here of both. And then we did this one. And this is where we left off. Is that correct? All right. So now we're moving on to this one. All right. So get a graph paper in front of you. You should have an extra graph paper from yesterday, yes? Not the handout that you got right now. You should have a graph paper. Copy this one. We're going to do this one together. And it reads, graph the function f of x equals x cubed. Graph the function f of x equals x cubed. If you ran out of graph paper, then go grab one. Hurry up, please. So, let's see. What is the first thing we do, Caesar? A table, x, f of x. What values for x, Geo? -2, -1, 0, 1, and 2. Okay. So far so good, yes? All right. So with that said, we substitute -2 in here, so we end up with -2 cubed. So what is -2 cubed? Tell your neighbor, -2 times -2 times -2. Very good, -8. Next value, -1 cubed. -1 cubed is -1 times -1 times -1, which is -1. Very good, Mario. All right. What is 0 cubed? 0. 1 cubed? 1. What is 2 cubed, Mario? 8. All right, let's graph that. -2, -8. -1, -1. 0, 0. 1, 1. 2, 8. From left to right. Make sure you curve it a little bit right here. Arrows at the end. Since this is the original one, we label it f of x. All right, but now they want us to transform it according to this. G of x equals f of x plus 7, and then outside of the parentheses, plus 2. Write that down. So before you tell your neighbor, look at it first. Look at this number. What is this number going to do? And what is this one going to do that's inside with x? Now talk about your neighbor. What is that going to do, and what is the other number going to do? All right. Looks like Dana's got it. I see you, Dana. All right. Denise got it. I see you, Denise. Let's go with Monse. What are we doing? Put to the left 7 and up 2. Hands if you agree with that. That is correct. 7 to the left, 2 up. So I'm going to start with this one. 7 to the left, 1, 2, 3, 4, 5, 6, 7, and 2 up. This one, 1, 2, 3, 4, 5, 6, 7, and 2 up. And then 1, 2, 3, 4, 5, 6, 7, and 2 up. And we label this G of x. G of x. All right, we good? All right, send that in, please. I want to see what you did. All right? All right. Let's do one more. Copy this one on the other side of the graph paper. Example number 3. And write graph the function f of x equals x squared. Graph the function f of x equals x squared. Then underneath, I want you to write in red at g of x equals f of x minus 6 plus 4. And then in blue, g of x equals f of x plus 8 plus 5. In green, g of x equals f of x minus 2 plus, and then outside of the parentheses, negative 10. And g of x equals f of x plus 4, and then minus 3. All right, get us started. What is the first thing I do? What is the first thing I do, Enrique? Potato. Oh, a table. I said potato. I was like, what? X, f of x. Talking about potatoes. Yesterday, I went to Rally's, and I ordered, they sell this one little box that has fries with, like, I don't know if they're chicken nuggets, but they're like little chicken bites, I guess they call them. And then I get home, and no chicken bites and no fries. All they gave me was a box with fries with a bunch of sour cream. I'm like, what? No. Was that? I gave it to my mother-in-law, so, yeah. But I called right away, and they're going to hook me up today. Let's go. And they said they were going to give me something else. And I'm like, all right, hook me up some wings. All right, so I need values for f of x. We got, for x, we got negative 2, negative 1, 0, 1, 2. By now, this should be automatic. Tell your neighbor what f of x is for each of those. By now, this is automatic. All right, Julissa, go. 4, 1, 0, 1, and 4. That is correct. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. And we label that f of x. All right? So I'm going to give you a head start so that you guys can do all the 4 transformations, combination transformations for each. So, go. All right, stop really quick. Show your neighbor what you did for the first 2, the red and the blue. And then I'm going to have Ashlyn get us started. But show your neighbor first what you do for the red and the blue. All right, Ashlyn, what do we do with the red one? Where does it go? 6 to the right and 4 up. Hands if you agree with that. That is correct. So 6 to the right, 4 up. And we label that g of x. The blue one. Ashlyn, pass him one. Caitlin, what does the blue one do? Left 8, up 5. Hands if you got that. That is correct. 8 to the left, up 5. And that's our new g of x. All right. Let's go to the green one. Share with your neighbor what you did with the green one, please. Then Caitlin's going to pass someone. What'd you do with the green one? All right, Caitlin, pass someone. Mario, what do we do? 2 to the right, 10 down. Hands, have you got that? That is correct. 2 to the right, 10 down. That's g of x. And I'll leave the last one for you to do. Send me your work, please. I want to see what you did. All right, from 1 to 5, how comfortable are you with this so far? Yeah, we got this, right? 5, 5, 5, 5. Okay, because we're about to crank it up a little bit. Okay. All right, so with that said, get your handout in front of you, please. Go to example number 4. Example number 4 should look like this. If you have a highlighter, change the color of the bottom one to blue or some other color. Example number 4. Hurry up, hurry up, hurry up. If you don't have it, then you probably got the wrong handout back there. So, all right, y'all ready? Here we go. I'm going to do this one together with you, step by step. This is how the home plate is going to go. So it says, the graph of the function f of x equals x squared is shown. Do you guys see that here? Yes, there it is. A transformation was done, and the new function g of x is shown, which is over here. Write the new function according to the transformation done. So, let's do this one together. Here we go. I want you to write Roman numeral 1. Step 1 is you write your form. G of x equals f of x minus h plus k. All right? Step number 2. We substitute values for h and k. H and k, according to whatever the transformation. So, before we move on, look up. If this is the original one, now let me give you a hint. Look up to the screen. Me, I like to focus on the very most simplest point on the function, which is what? 0, 0. So if you focus on this point, and if you follow it all the way over here, tell your neighbor what happened to that original function to get us over there. Talk it over your neighbor. What happened to the original function to get us over there? All right, looks like Mariah's got it. Very good, Mariah. Well, let's go with Kelly. Kelly, what happened to the original one to get us all the way over here? Move to the right, how many steps? 6 steps to the right. Hands if you agree with that. That is correct. So whenever we go to the right, it's a positive number. So we got positive 6 so far to the right. Okay? Then we move what else, Kelly? Down how many? 8 down from here. So we go all the way over here, and it looks like, yes, down 8, or that's down being a negative. So that's that. So now, which one is which? Which one is H and which one is K? Tell your neighbor. Which one is H and which one is K? Kelly, pass someone? Caitlin, which one is H and which one is K? Negative 8 is K. Hands if you agree with that. A K for K. That means that the other one is what? H. So label that. And now we know what to substitute where. So here we go. I'm going to change color so that you guys can see it. H is positive 6. So I'm going to just write positive 6 in here. And K is negative 8. Negative 8. Are we there so far? Yes? Right now, I'm going to go to the third step. All right? So, some of you are saying, Mr. Q, that looks weird with a negative and a positive. Yeah, I'm doing this for a purpose because when we move the other direction, I want you to see what happens to those negatives. Does that make sense? So, step 3, once we do the substitution, we rewrite our transformation. G of x equals f of x. What is positive times a negative? Negative 6. And then outside we just have minus 8. Hold on. We're not done. One last little thing. How do we know this corresponds to the original function? How would we know that it corresponds to that? Talk it over. What would I need to add to this so that we know that it corresponds to that? Tell your neighbor. What would I need to add at the end? All right. Looks like Monse's got it. I see you, Monse. Julisa's got it. Well, let's go with Joseph. What would I need to add to this so that we know that it corresponds to this function? The 2. That is correct. Put a little exponent of 2. And that's how we know that it corresponds to the original parent function. All right. Send me a picture of your notes, please. Woo. So as you're sending that in, here goes the process one more time. We start off by writing our general rule. Here it is. Step 2, we rewrite it, but without the H and the K. We look at the transformation done. We identify H and K and do our substitution. And step 3, we just rewrite it with whatever exponent corresponds to the original parent function. All right, from 1 to 5, I'll come to borrow you with that. 4, 4, 4, 5, okay. Shall we do another one? All right, let's go to the next one. Example 4Q. So, I'm going to give you guys a head start. You should be able to do this one by yourself completely. Go. Huh? Go. Here we go. Step 1, what do I do? Rachel, tell me what to write. Step 1. Bless you. All right. Step 2, pass someone. Tell me what to write. Uh-huh. Two. Okay. Okay. Hands, have you got that? All right. A sense of disturbance in the force. All right. Let's try it again. Pass someone, Gabriel. F of x minus negative 8. All right, let me write it here. Negative 8 and 2. Hands, have you got it to right there? Looks about right. And step 3. If this is correct, because we went 8 steps to the left, 8 steps to the left is a negative 8. That's why we wrote negative 8. We just rewrite this as g of x equals f of x. Negative times a negative becomes a positive 8 plus 2. And what am I missing at the end? The cubed. There it is, so that we know it corresponds to the original. Hands, have you got that by yourself? All right. Send that in, please. right, so which brings us to this example Shazam Q. Here we go. At the bottom, there's a little table. You guys see the table? Yes? So we're going to fill this in. So we're going to use our general rule, but now instead of looking at graphs, we're going to look at just words being used in order for us to do the transformation, okay? Here we go. So, as I said when we introduced the transformations, I said we're going to start with three parent functions, f of x equals x, f of x equals x squared, f of x equals x cubed. All these have a name. The first one is linear because it gives us a straight line, so draw a little line here so that you know that the graph is going to look like that. A quadratic will always look like this. And a cubic, what do you guys notice it look like? Like this with a little wiggle in between. That's how the graphs are going to look from now on. That should be automatic, okay? And you'll move that up for those of you in the back. There it is. Like so. All right. So, now we're going to write our transformation from the original parent function with this transformation. Now, they don't say transformation so many steps. From now on, they're going to use the word what? Translate. The graph translates so many steps. So, to get us started, look up. We're going to start with our general rule. So our general rule is g of x equals f of x minus h plus k. All right? So here we go. Question. If we take the original graph f of x and they want us to translate up 3 steps, tell your neighbor which one of these is going to change, the h or the k. Which one's going to change, the h or the k? All right, good conversations. Which one changes, Denise? The k. Hands if you agree with that. That is correct because this one is saying you translate going upward 3 steps. So that means we substitute here. You're going to write plus 3. This, the h, goes away. You cross it out. And now we just rewrite g of x equals f of x plus 3. And that's my new transformation. Now notice that I didn't write an exponent. Tell your neighbor why not. Why didn't I write an exponent here? Yeah, because this x does not have an exponent. Everybody see that? All right. Do the next one together. Here we go. We start off with g of x equals f of x minus h plus k. And it says, translate 2 steps to the right and 4 steps down. Talk to your neighbor. Let them know what you're going to substitute and where. 2 steps to the right, 4 steps down. All right? So, 2 steps to the right. Where does that one go? Let's see. Sean, 2 steps to the right. What is that? The h. That is correct. And if it's to the right, that means it's a positive 2. Is that correct? All right. And then 4 steps down, obviously that's going to be our k, and it's going to be a what? Down is negative 4. So let's substitute values. Negative 4, positive 2, and we rewrite this, g of x equals f of x minus 2 minus 4. What's the only thing missing? Tell your neighbor. Everyone? The exponent, right? The exponent of 2. All right? Do the last one by yourself, please. As soon as you're done, turn that in, please. All right. Show your neighbor your transformation for the last one, g of x what? And then we'll have Jesus give us his final transformation for that one. All right, Jesus, g of x equals? Plus 2? Cubed. Okay. Hands, if you got that? That is correct. All right, we have 2 minutes for one last example. Let's go. Mr. Q, you always juice the clock, of course, from bell to bell. Look at this one. It's in the back. Let's do this one together really quick so you can have this as a sample. Graph the function f of x equals x cubed. Now let's see, look up, if you know how to graph this without a table. We've been doing it already for 2-3 days already. Tell your neighbor the 5 points for that one. What are my 5 points for that one? All right, looks like Joseph's got it, but let's go with Geo. -2, -8. -1, -1. 0, 0. 1, 1. 2, 8. Okay, so that is our f of x. And now we need to write a function for this translation. What does it say? It says 3 steps to the right and 6 steps down. Do you know how to write your new function, yeah? G of x equals f of x minus h plus k. You follow the steps, and that's how you do your last graph. Have a good one, everyone. Enjoy your home plate. See you guys tomorrow. Bye.